implicit. Here's the deal, you just take the derivative of everything with respect to x, which is a little strange for some people. So this derivative is not that big of a deal, it's going to be 6y, but I have to take the derivative of the guts as well. And in all these cases, what was the derivative of y? The derivative of y was always y prime. Notice, every time I took the derivative of y, I got y prime as its derivative. The derivative of y wound up being y prime. The derivative of y was y prime. The derivative with respect to x, notice, what's the derivative of just the guts? X is 1, so I multiply that by 1. So even though we didn't use the chain rule, we actually did. So 6y, now the derivative of y, from time out of mind has been y prime. Plus the derivative of x squared, which is 2x. Now recall, I take the derivative of x with respect to x, that's just going to be 1. So I don't even bother multiplying times 1. Equals the derivative of 5x, which is just 5. Now, all I want to do is solve this for y prime. Most of the time when we did it formally, notice we got y prime equals. So I want to get this to y prime equals. So I'm going to minus 2x from both sides. This is going to give me 6y, y prime, equals 5 minus 2x. And then I divide both sides by 6y. And my final answer is going to be y prime equals 5 minus 2x all over 6y. And that is my final answer. Multiple derivatives. First derivative, second derivative, third derivative. First thing I want to do is rewrite this so I can just use the power rule. I'm going to rewrite this back end as x to the negative 2 and then just take the derivative of each term. 5 times 6 is 30. X to the 4th, I minus 1. 4 times 2 is x to the 3rd because I minus 1 from the exponent. 2 times 2 is 4x minus 1 just gave me 4x. Now negative 2 times 1 is negative 2x, and I subtract 1 from that to the negative 3. Now I'm not going to make you simplify that because we have multiple derivatives to take, so we're just going to leave that negative exponent where it is. So, again, the general power rule, 4 times 30, well that's going to be 120 x to the 3rd. Don't forget I'm still subtracting 1. Plus 3 times 8, that's 24 x squared, plus 4, because the derivative of 4x is just plain 4, plus, notice I'm putting a plus sign, because negative 3 times negative 2 is positive 6x, minus 1 is going to give me negative 4. Last derivative. 3 times 120, I believe, is 360. X to the 2nd power. 2 times 24 is 48. X, and I subtract 1 to the 1st power. Now when I take the derivative of 4, it goes away. It's just 0. But I take the last derivative of negative 4 times 6, that's minus, 24x to the negative 5. And I want to rewrite this last one with the positive exponent. So 360x squared plus 48x minus 24 over x to the 5th. I just take that x to the 5th and write them downstairs. The general idea for the antiderivative is you're bumping it up an extra exponent. So this is technically x to the 0. So the antiderivative of 5 is 5x. Don't forget, we have to add some constant. So there's a hidden 1 there. And I have to add 1 to that. So it's going to be 13x squared. But then you divide it by that exponent. And then you plus c. So the antiderivative is going to be 13x squared over 2 plus c. Antiderivative of e to the x is e to the x plus c. Yes, if you don't put the plus c, I will minus a point. Okay, you gotta put the plus c. You have to put the plus c. Antiderivative of 6x is 6x squared over 2, but that simplifies to 3x squared. Now I'm going to use something called Leibniz notation. And I take these limits of integration, the 0 and the 3, and I place them here on this bar, this denotation device. And it's going to be 3 times something squared minus 3 times something squared. And I have to plug in these values. The 3 goes first, and the 0 goes second. And this whole process here is actually called FTC 1, the fundamental theorem of calculus. 3 squared is 9. 9 times 3 is 27. Minus 0. So my final answer is going to just give me, show work and box the answer, 27. And integrals using a graph. All this means is what's the area. All the antiderivative is an area, the idea of area. So from negative 2 to 0, I need to calculate what the area is underneath that curve. And notice it forms the shape of a triangle. So the area of the triangle is 1/2 base times height. So this is going to be 1/2 times 2 times the height of 1, 2, 3. And that's going to equal 3. The area from 0 to 3 is the area underneath of this curve, or just a straight line. And I'm not even going to write the formula. It's just going to be 1, 2, 3, 4, 5, 6 boxes. Pretty easy. The area under the curve from 3 to 7 is half of a circle, or a semicircle. So it's going to equal pi r squared, and the radius in this case is 2. But it's only half of a circle, so I have to divide that area by 2. And that's going to give me 4 divided by 2 equals 2 pi. The area from 3 to 7 underneath this semicircle is 2 pi. The area underneath this rectangle is 6, and the area underneath this curve, or the area of this triangle, is 3. Now, from 7 to 9 is a quarter circle with a radius of 2. So the area of the entire circle would have been 4 pi, but it's 4 pi times 1/4, which is just going to give me pi. However, because it is below the x-axis, it is considered a negative area. The actual answer is negative pi. Tricky question. Using that same mentality, the area of this little triangle, 1 times 2, is going to be 2 cut in half, or 1, but it's negative 1, because it is underneath the x-axis. Last area is going to be the area from 10 to 15. From 10 to 15, or the area of this trapezoid. Area of the trapezoid is 1/2. The height, and the height of this is 2, times base 1 plus base 2. So base 1 is 1, 2, 3, 4, 5, plus base 2 is 6, 7, 8. That's going to give me 16 cut in half, just 8. Now I want the derivative. Given this graph. And anybody taking calculus should know there are 3 ideas in calculus. Limits, derivatives, antiderivatives. Limits have to do with how close you are. Antiderivatives we just showed was area, and the derivative is the slope. So I need to find the slope at negative 1. At negative 1, what is the slope of that line? Looks to me like it's going down 1, 2, 3 over 1, 2. Negative 3 over 2 is the slope of that line. This is a trick question. The slope at 0. Well, this isn't even a function, and it's a gap. If that y-axis wasn't there, I have like an open circle there. So the actual slope of this can't be found. So that's going to be a DNE. You can't find the slope wherever there's a jump, or wherever there's a sharp turn. If there's a sharp turn, you cannot find the slope. What's the slope at x equals 2? So 1, 2, what's the slope of a horizontal line? If I had Vux, Hoi, what is the slope of a horizontal line? 0. What is the slope at 3? Well, that looks like a sharp curve. You cannot take the derivative or find the slope at that sharp curve, so it is going to be DNE. It does not exist. What is the slope at 5? That looks like the very, very tippy top, doesn't it? The very, very tippy top. And the slope of anything touching that is going to be a horizontal line. So what's the slope of a horizontal line? The slope at 9. Can I find the slope at that point? There's a sharp turn, and those sharp turns have a special name. They're called cusps. So I have a cusp there, so I have to put DNE. At 10, can I find the slope at 10? Yes, I can. That's part of the line, so it's going to be up 1, 2 over 1, up 1, 2 over 1. It looks to me like it's going to be 2, because the slope is 2 over 1. Slope at 11. Am I allowed to find the slope at that sharp turn? No, it is called a cusp. It is not differentiable there. DNE. How about at 12? Am I allowed to find the slope of a horizontal line? And the slope of a horizontal line is 0. Whenever you see this, whenever you see the words write the equation, you're going to think about this equation. Y minus y sub 1 equals m times x minus x sub 1. Every time you see it, I go crazy. You got to know that, because they ask you to write the equation of a line, of a tangent line, to the equation at the given point, and the given point is 2, 7. I need to find a tangent at that, so I have a point, 2, 17. Now, that's my x1, and that's my y1. Now, all I need to write the equation is this thing called the slope. And there are 3 ideas in calculus. Limits, which is closeness, antiderivatives, which is area, and the derivative, which is slope. Okay? So in order to find my slope, I need to take the derivative of this at x equals 2. So the derivative of this is 6x squared at x equals 2. That's 4 times 6, 24. And now I can write the equation of my line. Y minus y sub 1 equals m times x minus x sub 1. Y minus 17 equals 24 times x minus 2. Now in Algebra 1 you might have been expected to keep going. In the calculus, I believe the furthest we want you to go is y equals 24 times x minus 2 plus 17. And that's about as far as we expect you to go. And that would be your answer. Number 52. Again, I have a point. Notice the point is 2, 16. I now need the slope. And in calculus, there are 3 ideas. Limits, which are closeness, antiderivatives, which are area, and derivatives, which are slope. So to find the slope for this equation, I have to take the derivative of this, which is 6x, evaluated at x equals this x value of 2. Well, that's easy enough. 6 times 2 equals 12. So my slope is 12. Y minus 16 equals 12 times x minus 2. Add the 16 to both sides. I'm going to get y equals 12 times x minus 2 plus 16. And Sophia, that is my final answer.
Same idea. I want to write the equation of a tangent line at the point pi over 4, comma 1. That's my x value. And this is my y value, 1. And now I need a slope. Now there are 3 ideas in calculus. Limits, which are closeness. Antiderivatives, which are area under a curve. And derivatives, which are slope. Okay? So I got to take the derivative of tangent evaluated at pi over 4. So I'm going to be a little bit more technical. D dx of tan x evaluated at x equals pi over 4. Now there's a couple of ways to evaluate the derivative of tangent. And one of them is using a scientific calculator. Here's the deal. If you hit math 8, it will take the derivative. And it gives it to me in the same format that I have written down there. All I have to do is type in the x, the function, tan x, close parentheses, evaluated at x equals pi over 4. And here it comes, which is 2. The other way to do it is to know how to find the derivative of tangent by hand. And there's a little trick to find the tangent by hand. The derivative of tangent by hand. And it goes like this. Secant, secant, tan. The derivative of secant is secant tan. And the derivative of tangent is secant secant. So this is going to give me the derivative of tangent is secant squared x evaluated at pi over 4. So this is going to give me the secant of pi over 4 times the secant of pi over 4. And this is one of the reasons why we learned a unit circle so well. Secant of pi over 4, notice, is root 2. So this is going to give me root 2 times root 2. And that's how I got my slope of 2. I now have to write the equation. Y minus 1 equals the slope 2 times x minus, yes, there's going to be a strange pi over 4 in your equation. One more step. Y equals 2 times x minus pi over 4. Add 1 to both sides. And that is your final answer.